Hello everybody and welcome. My name is Mike and this is an introduction to factoring using the greatest common factor. Okay, so today I want to discuss these six examples we have over here on the left side of the screen. These are typical examples you'll see when you're first introduced to factoring. But to be able to do these examples, you want to be familiar with the rules of exponents. So you want to be comfortable with working with these rules down here, okay, which are x to the m times x to the n is equal to x to the m plus n. So for example, if we had x cubed times x squared, we should get x to the 3 plus 2, which is x to the 5th. So we want to keep that rule in mind. The second rule we want to keep in mind is x to the m divided by x to the n equals x to the m minus n. So the top power minus the bottom power. Okay, so for example, if we had x to the 5th power divided by x to the 3rd power, we should get x to the top power minus the bottom power. So we should get x squared for our answer there. Okay, the key to using these rules here is that we have the same base. Okay, so the base in this case is x. You know, if this was x and this was y, we would not be able to use this rule here. Same for this division rule here. Okay, so let me go ahead and get rid of that. Okay, so now when we see the term factor, factor means a lot more than it really says. What we're really trying to do when the directions tell us to factor something is we're trying to find, in most cases, we're trying to find a prime factorization. In other words, we're going to try to factor these examples until we can't factor them any further. So all of these are working with a bunch of variables over here. Let me give you an example just using basic numbers here. So if I have the number 12 and I'm told to factor 12, I could do this multiple ways. I could say, all right, 12 is 12 times 1. Okay, that's one way to factor 12. Another way to factor it, I could say 12 is 2 times 6. And that's fine. Another way to factor 12 would be 4 times 3. Okay, so these are all different ways to factor 12, and it's good to be able to do this. Now, in these 6 cases over here, generally, when you're given cases like this, most times there's going to be one way to factor it. However, sometimes, if you're dealing with complex examples, you will see you can factor something multiple ways. However, the important thing to keep in mind is that however you factor these, they are all going to have a unique prime factorization. Okay, so in other words, this example is weird over here, but if I take a look at 12 being 2 times 6, I could further factor 6 as being 2 times 3. Okay, so ultimately 12 could be written as 2 times 2 times 3. Right? And I can't factor those numbers any further. These are prime numbers, so they're only divisible by themselves and 1. Okay, the same case over here with this 12. If I factor this 4 further, I see 4 is 2 times 2. Right? So again, this 12 here could be written as 2 times 2 times 3. Okay. So, and the same thing over here. If I factor this 12, it's going to end up being 2 times 2 times 3, no matter how you do it. So for a particular expression or a particular number, we're going to find it has a unique prime factorization. The same case is over here. No matter how you factor number 1 here, it's going to come down to a unique factorization once you can't factor any further. So in this video, I'm going to show you how to go about factoring these 6 examples. So let me get rid of this here, and then we'll take a look at number 1. Okay, so number 1, we are asked to factor 6x squared minus 3 times x. Okay, so ultimately with factoring, the definition is a lot more complex, but what we're trying to do is we're trying to break this expression up into pieces such that when these pieces are multiplied together, we're going to get our original expression. Okay. Now, that's basically what we're doing, but again, the definition is a lot more complex than that. Okay, so it's best just to see what we're doing through examples here. Okay, so in order to factor something like this, we're going to use the greatest common factor, meaning we're going to take a look at what 6x squared and 3x have in common with each other, and then we're going to divide that out of each piece. Okay, so to do this, we take a look at the 6 and the 3, and you want to ask yourself, what number will divide evenly into both 6 and 3? Okay. Well, just by looking at this, I know that 3 goes into 3 one time, and 3 goes into 6 two times, and that's the largest number that will go into both of these. Okay, so once I determine that, I'm going to go ahead and write that down. Okay. Next, we're going to take a look at our variables here. We have an x squared, and we have an x. So you want to ask yourself, what do these variables have in common with each other? What's the most that they have in common, in other words? So over here, since we have an x squared, that means x times x. But over here, we only have a single x. So what's the most that they share? Well, the most that they share is just a single x. So I'm going to go ahead and write that down. So this term here, 3x, right, this is known as the GCF, or the greatest common factor. And this is what you're going to need in order to find this prime factorization that I've been talking about. Okay? If you don't factor out the greatest common factor, you're not going to get the prime factorization. Okay? And that's going to, I'm finding that prime factorization is very important for future problems and solving equations and so forth. So that's why we do this. Okay, so once we decide what the greatest common factor is, we open up a set of parentheses and we're going to divide it out of each piece. Okay, so we're going to divide it out of 6x squared and out of 3x. Okay, so what we're literally doing, we're not going to do this in practice. Okay, I'll show you an easier way, but this is just one way to think about it. What we're literally doing is we're taking this first term, we're dividing it out by 3x, and then we drop our minus sign here. And then our second term is 3x, and we're dividing out the 3x. Okay, so that's what we're literally doing. We never really read it like this, though. So I'm just going to rewrite this here. We have 3x, a set of parentheses. And then we'll go ahead and do the division. 6x squared divided by 3x. This is where we need to know these exponent rules here. 6 divided by 3 is 2. X squared divided by x would be x to the first power, or just x. We drop our minus sign here. Then 3x divided by 3x is going to be 1. Okay, so this is the factored form. So we have this piece times this piece here. Okay, so we broke this expression up into pieces such that when these pieces are multiplied together, we're going to get our original piece. All right. So basically, that's the idea. Now, again, I mentioned that we don't want to think about it like, well, you could think about it however works best for you. But this typically isn't done in practice. But again, this is what you are actually doing. So let me show you another way. Once you find, let me get this here. All right, this was the first way. Let's talk about a second way, just to think about it here. Okay, so once you find the greatest common factor, which is 3x, open up the set of parentheses, and you may want to ask yourself, okay, what do you have to multiply 3x by to get 6x squared. Okay, this is going to be the easier way, I think. 3 times a 2 would give you the 6, and an x times an x would give you the x squared. Right? And then we drop our minus sign. And then 3x times what will give you 3x? Well, 3x times 1 would give you 3x. Right? So we obtain the same answer when we think about it like that as well. All right, so this second way here, this is probably going to be the way that you go about doing this once you're comfortable factoring these here. And let me show you, let me go ahead and show you a third way. I wanted yellow. Okay, let me show you a third way to do this here. We're going to take our original expression here, 6x squared minus 3x. Okay, and say we want to go ahead and factor this. Well, if we wanted to, we could break 6 up into 3 times 2. And then x squared we could break up as x times x. And minus 3x, well, 3 is just 3 times 1. I'll just leave it as 3, and we have an x here. So when factoring this, we're looking for the shared factors between these two expressions. And so what's shared between them? Well, we have a 3 over here and a 3 over here. So we go ahead and write that down. And then we have an x over here and we have an x over here. So we go ahead and write that down as well. And then we open up our set of parentheses and we're going to ask ourselves what is left behind after we take those out. Okay, and when I say take out, I mean divide these out. So what's left behind after dividing out the greatest common factor? Well, there's a 2 remaining here and an x. So the first piece in parentheses will be 2x. Then we have a minus sign. And what happens when you divide 3x out of itself? Essentially, you have a 1 sitting here, kind of just being there. We don't really write it, though, when it's not needed. So, but 3x divided by the 3x we took out should be our 1. Okay, so either way we go about, either way we think about this, we're going to get the 3x times 2x minus 1 as being the factored form of 6x squared minus 3x. Okay, so that is number 1. Let's go ahead. Now, for the rest of the examples, I'm not going to do the 3 ways. I'm going to do it the second way. Again, the second way is probably the most helpful way to look at these here. Okay, so now number 2, we have a bit longer of an example here, but the process is going to be the same. We have 8x to the 4th times y squared times z minus 6x to the 5th y z squared minus 4 x cubed y cubed. If you notice when I write the z's in math, z's tend to look like 2's sometimes, so to differentiate them from 2's, mathematicians will put a little horizontal line in between the z here. Okay. Alright, so here's our expression, and we want to factor this expression into its prime factorization. So in order to do that, we need to find the greatest common factor between these 3 terms here. Okay. Now, we're going to begin with the constant numbers. What number will divide evenly into 8, 6, and 4? Well, 2 goes into all of those numbers, and that's going to be the greatest number we could take out. If we go any higher than 2, like if we said 4, for example, I mean 4 divides into 4 and it divides into 8. However, it does not divide into 6 evenly. Okay, so the greatest number that will divide into each of those is a 2. And then for these variable terms here, x to the 4th, x to the 5th, and x cubed, you want to ask yourselves, what do these variables share amongst each other? So here we have 4 x's, x times x times x times x, and here we have 5, and here we have 3. Okay, so what's the most amount of x's that they share? Well, It turns out that it's going to be the lowest powered variable that you have. I mean, they share at least 3, because this one has 3 over here, this one has 5, and this one has 4. So they all at least have 3 x's. So that means we could take out x cubed. Okay, so again, you could think about it like that, or it's always going to be the least powered variable that you have. Okay, and once we get to z, I'm going to show you something about z here. Okay, but for the x's, we could take out an x cubed. Now for the y's, we have y squared, y to the first, and y cubed. So what's the most that they share? Well, they share at least a single y. This one has a single y here. This is y to the first. That's the lowest powered variable, so that's the one that we're going to take out. Now for the z's, we have a z to the first, a z squared, and over here, I mean, it looks like we don't have a z, right? So they all don't share a z, essentially, so we're not going to be able to take out a z. And if we think about what I said, we're going to take out the lowest powered variable, right? So it looks like the lowest powered variable is a z to the first, so why don't we take that out? Well, over here, if you think about this expression here, it doesn't contain a z, so in other words, you could say, well, it contains z to the 0th power, right? And z to the 0th power is 1. Okay, anything to the 0th power is 1. So you could think about there being a z to the 0th power over here, and if you stick with the idea that you're going to take out the lowest powered variable, then we're going to be taking out a z to the 0, okay, or a 1, or essentially no z's. So, you know, I'm not going to write that in, but you could think about it like that. Okay, so they don't share the z's, so we can't take out a z for the greatest common factor. So this piece here is going to be the greatest common factor, and once we have that, we go ahead and open up our set of parentheses, and we're going to ask what's left behind after we divide this out of each of these 3 pieces. Okay, or in other words, an easy way to think about it is, what do you have to multiply this by to obtain our original expression? So let's begin here. 2 times what will give me 8? Well, a 4. X cubed times what will give me x to the 4th? Well, an x. Oh, and this is where we need to keep this exponent rule in mind as well. Okay, so y times what will give me y squared? Y to the first. And then we have a z here, so we're going to need a z right here. Okay, so 2x cubed y times 4xyz should give me this expression here. Next we have a minus sign, so we go ahead and drop our minus. 2x cubed times y will give me, times what will give me 6x to the 5th y z squared. Well, 2 times 3 will give me the 6. X cubed times x squared will give me x to the 5th. Y times what will give me y? Well, just a 1. Okay, if it's just a 1, I don't really need to write it in there. And then what times what will give me a z squared here? Well, we have a z squared here, so we're going to need one right here. So 2x cubed y times this 3x squared z squared will give me 6x to the 5th y z squared. Next, we have a minus sign here, so we go ahead and drop that. 2 times what will give me 4? Well, a 2. X cubed times what will give me x cubed? Well, just a 1. Okay, but again, I don't need the 1 there, so I'm just going to leave it like that. Y times what will give me y cubed? Well, a y squared. And then we go ahead and close our set of parentheses. And this, what we have here, is our factored form. So we have this piece times this piece will give me the original expression. Okay, so this is, again, it's known as a prime factorization. We cannot factor either of these pieces. We can't factor this, or we can't factor this any further. This is as far as we could go. Okay, so that is number 2. Moving on to number 3. We have, now number 3 is similar to number 2, which is going to be extra practice. 4, 5, and 6 all have a different idea represented within them, but number 3 is similar to number 2. Okay, so we want to look at 14, 2, and 12. We see that 2 goes into all those numbers. Then we look at the x values. Well, they all don't have an x. I mean, this expression over here is missing an x, so they don't share an x, so we can't take out any x's. But how about the y's? We have y to the first, y to the fourth, and y to the fifth. How much do they share? Well, they all have at least a single y, so we could take that out in our greatest common factor. So now we go ahead and open up our set of parentheses. You want to ask yourself, 2y times what will give me this? Well, 2 times 7 gives me the 14. We're going to need an x cubed here. And then y times 1 will give me the y, but we don't need that there. Then we drop our plus sign. 2 times what gives me 2? Well, a 1. We have an x to the 6 here. Okay, so 1 times x to the 6 will give me the x to the 6. And then y times what will give me y to the 4th? Well, y cubed. And then we have a minus sign here. 2 times what gives me 12? I have 6. And y times what will give me y to the 5th? Well, y to the 4th. Okay, so we see that this is going to be the factored form of this original expression here. Okay, so like I said, this is very similar to number 2. Moving on to number 4. Okay, 4 looks easy, right? But we're going to have to keep in mind here that 84 and 140, they may be difficult numbers to work with. Okay, so to find the GCD, we want to find the GCF. We want to find the largest number that goes into both 84 and 140. And by inspection, just by looking at these numbers, it may be a little bit hard to do. So, for example, we see, okay, 2 goes into 84, and it also goes into 140. But what if we go higher than that? Well, we see that you may see 4 goes into 84, and it goes into 140, right? But going any higher than that, it may be a little bit difficult to see. So here's how we're going to find the greatest common factor of 84 and 140. So the largest number that will go into 84 and 140. The idea is to make factor trees. So we want to factor 84. So 84, you could say, let's say it's 42 times 2. Okay, and 42, we could say, is 6 times 7. And 6, we could say, is 2 times 3. Okay, so the prime factorization of 84 will be, so 84 is, we have a 2 times 2 times 3 times 7. Okay. We're going to do the same thing for 140. So we go ahead and write down 140. We could say 140 is 14 times 10. You could say it's 70 times 2. It doesn't particularly matter. We're going to get the same prime factorization no matter how we go about factoring 140. So 14 we could say is 7 times 2. And 10 we could say is 2 times 5. So the prime factorization of 140 will be 2 times 2 times 5 times 7. Okay, so if you want to know the greatest common factor between 84 and 140, we look at what factors they have in common. So for 84 we have a 2. And 140 we also have a 2. So the GCF, the greatest common factor, will have a 2, a factor of a 2. Now in 84 we have another 2, and in 140 we also have another 2. So we'll have another 2 in the GCF. This one has 3. 84 has a factor of 3, but 140 doesn't. So 3 will not appear in the GCF. But 84 has a 7, so does 140. So a 7, a factor of 7, will appear in the GCF. And we see that 2 times 2 times 7 will give us 28. Right? 4 times 7 gives us 28. So 28 is going to be the greatest common factor between 84 and 140. So when we go to factor this now, let me factor it down here. When we go to factor that, our GCF is 28 for 84 and 140. Then this one has an x, but this term over here does not, so we can't take out any x's. This term here has a y, but this term does not, so we can't take out any y's. Okay, so the GCF is just 28. Now 28 times what will get us back to 84? Well, you may have a calculator, but let's see, 3 is going to do the trick there. And then we have an x. Okay. And then 28 times what will give us 140y? We'll see. Let me drop the positive sign here. We have a plus. 28 times 5 will give me 140. And then we have a y sitting right there as well. So 28 times 3x plus 5y will give us our original expression. So we could see that this is now the factored form. Okay. So when you're working with large numbers, in all these previous cases we had relatively small numbers, so it's just easy to look at and find what's the largest number that's going to go into each of these numbers. But when you're dealing with an 84 and 140, it's not so obvious maybe to see that 28 will be the largest number that goes into both of these. Okay, so you want to keep this method in mind, these factor trees here, to find the GCF. Okay, now moving on, we have number 5. This is negative 12 x squared plus 33x. Okay, so I wanted to put this example here just to demonstrate that we could always take out a negative, or we could always factor out a negative. This may be useful for future cases. So we're going to look at negative 12 and 33. So essentially for 12 and 33, what's the largest number that will go into both of these? Well, 33 is 3 times 11. Okay, and that's it, right? So either you could take out a 3 and 11 or nothing. We also see that 3 goes into 12, so it looks like 3 is going to be the greatest common factor between 12 and 33. But let me go ahead and take out a negative 3. You could always take out a negative if you would like, and I want you to see what's going to happen when we do that. So we're going to go ahead and take out a negative 3. Now we have an x squared here and an x here. What's the most that they share? Well, just a single x. Okay. Then we go ahead and open up our set of parentheses. Now 3 times what will give me the 12? Or negative 3 times what will give me negative 12? And the answer would be 4. And then x times what will give me x squared? Well, an x. Okay, then we have a plus sign here. Negative 3 times what will give me a positive 33? Well, it's going to be a negative 11. Okay, so instead of writing a plus here, since we have a negative 11, I'm going to write it like this. Okay, and then x times what will give me x? Well, 1. Okay, so this is the factored form. When you factor out a negative, what it's going to do to the expression is it's going to change the sign of each of these here. So originally we started with a negative, but here we have a plus, or a positive, and here we have a positive, but it's going to change to a negative. Okay, so whenever you factor out a negative, the signs it's going to change the signs of whatever is inside of the parentheses. Okay, so you want to keep that idea in mind for future examples. Okay, moving on to the last example here, we have number 6. Now 7x times y plus 5 minus 4 times y plus 5. All right, so the difference here for number 6, as opposed to the other examples here, is that we have these y plus 5 binomials here. In each of the previous 5 cases, we were factoring out something called a monomial. Essentially, a monomial is an expression that's glued together through multiplication or division. You won't see any pluses or minuses in a monomial. Okay, so here, however, when we look for what is in common between these two terms here, we see that there's a binomial in common, right? Y plus 5 is a binomial because it's an addition of two monomials. Y is considered a monomial. 5 is considered a monomial. When you combine these monomials through addition or through subtraction, you obtain something called a binomial. If you have 3, you're going to get a trinomial. And more than that, we call a polynomial. So in this case, we're going to have to factor out a binomial. Now, we may want to look, do we have something in common between 7x and 4? No, we don't. So we do see that they have a y plus 5 in common, though. So we do this the same way we factored out the GCF as before. We go ahead and write down our GCF. Okay, so we see they have a y plus 5 in common. We open up a set of parentheses. That's not good. Open that up there. And we're going to ask ourselves what is left behind after we divide out y plus 5 from this piece and this piece. And once you divide y plus 5 out of the first piece here, you're left with simply a 7x. Or again, you may want to think about it, y plus 5 times what will give me this piece here? Well, a 7x. Then we have a minus sign. And y plus 5 times what will give me this piece here? Well, we need the 4. Okay, so we go ahead and write that down. And that's the factored form there. So we have a binomial times a binomial for the factored form. Now, this is going to be useful when we go to do factoring by grouping, which I will cover in a different video. Okay, so I hope you learned something. I hope you have fun factoring these examples here. So try this method out on your homework or on the test or a quiz or whatever's coming up, and I'll see you in the next video. See ya.